Hello, I'm Michael Wybrow. In this video, I'm going to talk to you about core data, which is the sort of main topic that we're going through. And this is going to take a bit longer than some of the other videos because this is a deep topic and it's not something I can easily split up into convenient little pieces. But this is something that is really important to know about iOS programming. All right, so let's get started. What is core data? It's an iOS framework, and you can think of it as representing the model component of MVC. It's available on both iOS and macOS, so you can use it between apps. It's also a high-level abstraction, and it's managed. And this means that you're not dealing with like low-level database level things. You're working at a much higher level in terms of like objects and the connections between them, and most of that complexity is abstracted away. Indeed, core data can make use of different storage mediums as to back it. So it can be saving to XML files, or it can be saving to SQLite databases, and you don't even need to know that. The high level interface you use to it is mostly, I should say, agnostic of that. So how does core data work? Well, first of all, to use it, we need to create something called a core data stack. And basically, this is a group of classes that are responsible for saving data to and retrieving data from what's called a persistent store. And a persistent store is just a kind of storage. So the persistent store could be XML files, it could be a SQLite database, or it could be something else. And what does the persistent store actually contain? It basically contains objects and references between them. So here's some classes or terminology that you're going to need to know when we're working with core data. You're going to have managed objects, and managed objects represent records that are managed by core data. So when we fetch information out of core data, what we get back are managed objects, and they have connections, references between them. So these managed objects are stored in what's called a managed object context. And you can think of a managed object context as basically like a container, but one thing that might not be particularly kind of obvious to you or logical is that there can be multiple of these. So you can think of them as a sort of scratch pad for testing out some possible data that you're going to store. And they can be saved and then they become persistent, but otherwise you can sort of throw them away. So you can think of them as basically just an object space in an application. And what do they contain? They store these managed objects. So then we have a managed object model, and this is like a schema. You can think of it like a database schema. It tells you what managed objects can exist and what connections they have between them. And this is something we would define in Xcode, and Xcode has a special editor for working with the managed object model. Then we have a persistent store coordinator, and this is the thing responsible for storing managed objects and determining how they're actually persisted. So usually you create this once at your application launch, and then you don't really worry about it. So here's a kind of mapping. We have the persistent container, which is called, and these are the class names, NS persistent container. We have the model, which is an NS managed object model. We have the context, NS managed object context. And we have a store coordinator, which is an NS persistent store coordinator, which talks to the database. All right, so when we're working with our data, as I said, Xcode has a modeling tool where we can create the managed object model. You can do this by saying file, new, core data model, or alternatively, when you create your project, there's a little checkbox in that wizard when you're creating your project, and you can just specify that core data is being used. The modeling tool that's built into Xcode allows you to create entities and specify attributes, which are basically like properties. And you can do this visually, so you can see a kind of entity relationship diagram where you can see the objects and their connections. Now, important consideration, you're modeling objects, that is classes, instances of classes, you can think of them, not database tables. So you kind of need to think about it. Don't think of it as just being a relational database, like a SQL database, because that's not what core data is. Even though there's some similarities in terms of like fetches being like queries, for example. All right, so this is the modeling tool. You have a list of entities on the left here. There's a plus button that you can use to add new ones. When you select any one of these entities, it has a number of attributes, its properties. Each of them has a type that match the Swift types. Each of them has a name. And then you have relationships, where in this case we've got a game entity, and it has a relationship called consoles, which is links to this other entity, and then there's an inverse relationship too. So the console has games that link to the games, and these can be one-to-one relationships, or one to many, or many to one, or many to many. Okay, so the nice thing about these entities is that Xcode can generate classes for us. So we define these, but then we end up with classes that are subclasses of a type called NS managed object. So these are what, when we talk about NS managed objects, we can end up with a class like game, and it has a number of properties that match the attributes, and it will have methods created that allow it to set up and read the relationships, and that means we can work with it kind of like an ordinary class within our app. And then there's some built-in helper method for fetch request that tells you what basic fetch request you would need to use to load all of the entities of this type. Okay, so the first step of using core data is to create a core data stack. If we ticked core data when we first created the project, it's done for us. Okay, so we only need to worry about this if we've got an existing app and we're now adding core data to it. I'm going to spend a minute or two talking about this, because this construct is not something you've seen before. Okay, we said we need to write the following code. This is something that would go in our app delegate typically. So you can access it from all throughout your app. Here, persistent container is a property, and it's a property of type NS persistent container. What we haven't seen before is we haven't seen this lazy keyword and then the assignment, where the assignment, instead of being an actual value, is a block of code. So this swirly brace here down to this one and the parentheses on the end are basically saying here's a block of code and we're going to execute it. Now that makes some kind of sense. That means to figure out the value of the persistent container, if we want to access it, we need to have run this code, and this is going to set the value of the persistent container. Now the lazy part has the behavior. The lazy keyword tells it that if you never try and read this persistent container property of your app delegate, then this code never gets run. The very first time you try and access persistent container, it's going to run this block of code, return the container, and it's going to be saved into this property and return to whatever code was accessing it. The second time you access that property, it's just going to return the value that was stored. So this is a nice lazy is a nice way of lazily evaluating something only if you need it. So the first time it's needed, the code will be run, it'll be evaluated, and then subsequent times it just uses that value. So that's what that does. The code here is somewhat boilerplate code. I'm not going to explain it in great detail. Basically, just we're creating an NS persistent container. It has a name, week 4. This is basically the name of the data model within the app. You can have multiple. Typically, an app is only going to have one. We ask the container to load persistent stores, and if we have a look at this method, load persistent stores, and I'll show this in the workshop, it returns back a, or rather, sorry, we're passing to it a block here, and this block is basically a handler that gets called when it complete. It's a completion handler. I think it's actually called a completion handler. Is the name of the parameter name, and it's going to load these persistent stores. It does that asynchronously, so it's not going to do it immediately. So this part from the swirly brace here down to this point, here, is the completion handler. And the completion handler is like a function, if you like, but it's just written in place here. It's got two parameters, a description and an error. And then the body of it is everything after the in keyword down to here. And this looks a bit weird because I said, okay, we're passing to the persistent stores here a completion handler. But what you're actually seeing is there's nothing passed to it here inside the parentheses, and there's just this block following it. This is what's called trailing closure syntax. If you have a look at the documentation for load persistent stores, it indeed does have a completion handler, a single argument completion handler, and that single argument is a block or a closure with two arguments and no return value. So this, what happens here is that it gets given the description and an error. Both of them are optional. We check if the error is an error, and if it is, then we show a fatal error, and if it isn't, then the persistent stores have loaded correctly and we can just carry on. Okay. And again, with this, you don't need to write this yourself. Typically it's being added to the app, or if you need it, you can just copy and paste it. So if you don't fully understand it, please come and see me and ask in a consultation or whatever. I can go through it in more detail, but it's not strictly necessary to have a great grasp of this. Okay, so how do we fetch data from core data? To do this, we use what's called a fetch request, and we saw before that the generated managed objects actually have a method that gives us a basic fetch request. And when we've got a fetch request, we ask the managed object context to perform that fetch for us. So how might we do this? Well, typically we need the managed object context first. That's something we would usually access from the persistent store and then access via our app delegate. So we might do something like this. We might first get an instance of our app delegate, which is a custom subclass of the standard app delegate. And that's just in the appdelegate.swift file in our project. So we ask for the shared delegate. We check that it can be cast to this type, which we assume it can. So this really should never fail. If it does fail, we're just returning and doing nothing. We could have an error message here too. And the guard statement just allows us to know anytime after here the app delegate is non-nil and we can use it. So then we access the app delegate's persistent container. That was that method we just talked about, or that property we just talked about, sorry. And then it has a property itself called view context, and this is our managed object context. Once we have this, here we just have, this is where we're going to put the results. This is an array of games. Initially it's an empty array, and here's where we actually do the work. we take our instance of the managed object context and we asked it to perform a fetch. The fetch it will perform, we can give it just a basic fetch request that the game managed object context gives us, and we know that it's going to return any game objects in our core data model. So we can safely cast this to an array of those NS managed objects, game objects. This whole thing can fail and throw an error, so again it's in a do catch block like we talked about before. Now, when you fetch things from core data, you might not want to fetch every like if you're fetching a particular entity, you might not want to fetch every single one of them. You might want to select some subset with some particular attributes. So what do we do here? You can, and actually, I should say first, before we choose to select particular things, you might also want to fetch them in a particular order, which is actually what we're talking about on this slide. So you can do the ordering thing with what's called a sort descriptor. So you create a sort descriptor for a particular property, in this case name, and you attach the descriptor to the fetch request before you execute it. So what would this look like? We'll create an NS sort descriptor. We give it a key, which is name, and you tell it whether you want it to be ascending or descending. And you create the fetch request as you did before. That could be just via that fetch request method of the game type 2. And then it has a property called sort descriptors. This is actually an array, so we give it 1 here for name, but you could sort primarily on name, and then if the names match, you could sort on something secondarily. So you can give it an array of multiple sort descriptors if you like. From then on, the code looks the same. We ask the context to perform the fetch, and we pass it the particular fetch request, and we cast it to our array of games. Okay, so we can also use predicates to select particular data. So in this case, this example is showing how to select only games that begin with an S. So how do you do this? Well, you create an NS predicate. The predicate uses a format. This is a bit like C format strings, with printf, where this part where we've got percentage and the @ symbol matches any Swift types. So we can we can list multiple of these, and we can then list after additional commas what class instance is, or just string literals or whatever, and they get put into this format string. So here there's a certain syntax that's needed. So we basically say a property name contains, and then this is a character, and then we specify that character. And the rest of this looks pretty much the same, apart from we take that predicate and we assign it to the predicate property of fetch request. So you can combine predicates and sort descriptors if you like. So you can both select a subset of the data and order it. That works fine as well. Okay, so that's the sort of fetching part. How do we add something new to core data, especially when nothing exists there at the beginning? We do this through the managed object context. We ask the managed object context to create an object for us. We do this by using NS entity description. It has a method called insert new object. We need to specify the entity name. This is just what was listed for the entity in the model, and we tell it which context we're inserting it into. Then it's going to return to us an NS managed object, which, if we've generated specific classes for these, we'll know it's of that type, and we can safely force cast it to the type game. And because it's because it's cast to this type game, we know game just has standard properties, and we can refer to them like this via the property names, and this sets the attributes in the core data model. And you can create a new one, set its name, set its developer, set its publisher, set its release date, etc. Now, we talked about NS managed objects as being scratch pads. So one thing to note here is once you've done this, the object is in the managed object context, but it's not persisted to the store. So if the app was just crashed or closed here, that data wouldn't actually be in core data. And that's because the managed object context, you can think of it as dirty. It's in a state where there's some draft changes there, but it hasn't yet been saved. And it's only when you save the managed object context that those changes get persisted. So how do we save the context? We can update and change objects as much as we like, and you do that just by inserting new ones, changing their properties, or changing the properties of existing ones. And then when we call save, those changes end up in our database or our XML file or whatever is storing core data. So we can check whether the context has changes, as in there's anything that needs saving. If there is, you can try saving it. Save can fail, though it shouldn't. So again, you can do this do try catch block, and in this case, because we know like this shouldn't really save, we're performing a fatal error here and just saying something went seriously wrong. The context can't save, which might be because the device is like completely out of space or something. Okay, we've talked about adding an object to core data. How do we delete something? We delete it pretty easily. We just, the context has a method called delete, and we give it an NS managed object or subclass, and it will delete it. Again though, that deletion is a draft deletion. It's only when you save the context that that change is persisted to core data. Something else I should mention is it is possible to do updates to your model. That means like if you have a shipping app where people have things stored in core data and they want to, or you want to make a change to your database model to add, I don't know, new properties to one of your entities, you can do that. And Xcode and iOS have a method where you set the mapping and the different version numbers and things, and it will migrate data across with some limitations on syncing and other things, and you have to be a little bit careful with it. This is not something we're going to go into in the unit. I'll mention that it exists and you could read more about it, but in our case, because you'll, for your own apps, be developing them yourself and not shipping a version to customers or anything else, you can revise your data model and then just repopulate the data in it yourself. So, I mean, you should really only have one data model, even if you've gone through a couple of revisions or iterations of it yourself in your final app. So you shouldn't need to worry about the versioning, is what I'm saying. Yeah, so look, there's a lot that I've gone through in this talk, and it's been a long video. I'm going to spend some time in the workshop this week where I'll take our movie application from last week and I'll show how we can use core data to store some information between app launches. So I'll talk about a lot of the stuff you've seen here, and you'll get a chance to ask further questions as part of that. Okay, thanks for watching.